Okay, well, welcome everyone. My name is Drazen Fabris. I'm the chair of the Mechanical Engineering Department, and this year for Preview Day, we're going to actually do this presentation virtually. So I'm going to go through and present some slides. Normally, there's a question and answer session where students and parents and you guys get to ask us questions about how things work. We're going to try to answer those questions separately. So at the very end of this presentation, there are going to be a couple of links for some more information and how to get a hold of us so that you can ask any questions. But what I want to do in the next 20 minutes is describe the Mechanical Engineering Department, what mechanical engineering is, and I'm also joined today by Felicia Franz and Valeria Avila Guerrero, and I'm going to have them introduce themselves.
Hi everybody, my name is Valeria Avila Guerrero. I graduated from Santa Clara University in 2018 in mechanical engineering, and then I continued on to my master's currently in robotics and mechatronics. I was also working part-time at a manufacturing company nearby, so I got to do some estimating and some design work in manufacturing, so that was pretty good. And I'm currently a machine shop assistant for the Mech 101L class that we'll talk about later, and I also assist with a machine design class.
Hi everyone, I'm Felicia and I'm a graduate student at SCU, and I graduated from my undergrad in SCU at 2018, and after graduation I worked as a mechanical design engineer for about a year before I decided to pursue my master's degree in robotics and mechatronics in SCU again. I'm also currently the TA for machine shop and also the senior design capstone course.
All right, so as I mentioned, what I want to do today is describe for those of you that are not as familiar what really mechanical engineering is, and then talk more about what the program is at Santa Clara. Talk about our department mission, the department achievements, some things on our curriculum and their structure, information about our students in terms of the demographics, examples of some of the things that the students do, and talk about some of the opportunities at Santa Clara. And then at the very end of the presentation, there are a few links for follow-up information for those of you that are interested. And then you can send us questions and we'll find a method to respond back and provide these answers to you. First off, what is mechanical engineering and why would somebody do mechanical engineering? Well, if you find yourself interested in understanding how things work, if you like to build things, if you like to design things, if you've had a fascination with cars, robots, aircraft, all of these kinds of things, then mechanical engineering might be a good field for you. If you are good at physics and mathematics, those are other things that we use very heavily. So if you're interested in a career where you get to apply this and do really interesting, exciting things, then mechanical engineering is the field for you. And for each of you, one of the things we ask or look for is that you find your own reason. So we really want you to have a major or field that you're interested in that is fulfilling, and then you'll get the most out of your career. What is mechanical engineering? Well, when we think of mechanical engineering, we think of a wide variety of things. We think about designing individual parts, understanding how materials and these things work and respond. We think about cars, we think about things as large as turbines, understanding the physics of aircraft and flow behavior, and even up to the scale of large manufacturing plants. And these all involve mechanical concepts, applications of mechanical engineering, and these are all things that we cover or touch upon in our educational program. From the Society of Mechanical Engineers, they come up with a description of what mechanical engineering is, and I'm going to move our photos off a little bit to the side so we can cover this. And so ASME is the American Society of Mechanical Engineers, and they have a definition that says that if something moves or uses energy, then mechanical engineering is probably involved in designing that thing or understanding that device or mechanism or machine. We create and develop mechanical systems that are used in a wide variety of applications, and it's for the societal benefit find better solutions or better methods of doing things. We enhance safety, economic vitality, and provide lots of devices that make our lives better as a whole. Mechanical engineering as a formal profession is the second oldest and broadest of the engineering disciplines. Now, to talk a little bit about what the different things are that mechanical engineers do. If we have to design a device where there's some type of motion or a structure that holds something up or something that has an energy conversion and power, then that involves mechanical engineering. If we have to design things where we have to control a system and deal with inputs and outputs and understand how that system behaves, that also involves mechanical engineering. We design products, we design manufacturing lines, and we even do research and development. In all of these slides, I've included photos of activities that we do, projects. Many of them are senior projects, some of them are junior projects, some of them are research activities. So throughout the presentation, you can see some of the types of things that students have built. And our curriculum put together is composed of a number of sub-disciplines, including dynamics, fluid dynamics, materials, thermal controls, materials and machine components and design. So the curriculum covers all of these basic areas, and I'm going to have Valeria talk a little bit about what her interest is and why she is engineering.
So I've always been interested in how things are made and the materials used and the manipulations we can do to materials to get them on that form. So that falls under materials and manufacturing and also machine design, machine components in the sub-disciplines. And we have a couple classes that I really enjoyed in our curriculum, like Mech 11, which is materials and manufacturing processes. And we really got to understand how we can transform steels into the form we need them, or plastics, which was really interesting. And we also have machine design class where juniors get to work on a project and they'll get their own take on the steam effort. Right now, juniors are working on an apple juicer, which is really interesting. They have to really think about the force that the user has to apply and how to get the juice out of it. I really enjoyed those classes because of the process of making and the materials that we use.
All right, thank you. All right, so that's a little bit about what mechanical engineering is. In terms of how mechanical engineering is as a career, it's one of the broadest of the disciplines because there are many different facets and different pieces to mechanical engineering to study and to apply ourselves. So nationwide in the US, we have over 300,000 jobs in the US, and these jobs generally fall into areas of machinery, manufacturing, transportation, components, architecture, scientific research, and we're also anticipating a growth rate in mechanical engineering over the next decade. Now, let me talk about Santa Clara and what the Department of Mechanical Engineering looks like at Santa Clara. So our department mission is to provide an education for students that will give them a broad grounding of engineering fundamentals, strong communication skills, the ability to adapt to changing work environments, and an appreciation to understand the impact of engineering work on society. We try to have a program that has a good balance between theory and practice in how our classes and our program is structured. So fundamentally, our Santa Clara program is a very strong foundational program at the undergraduate level. We're accredited by the Accreditation Board of Engineering and Technology. We integrate the technical aspect of our program with the value-based core curriculum of Santa Clara University to provide breadth, and we feel that this is a good blend between practice and theory, leading to, in the senior year, a capstone project where students get to use their skills to design something that they're interested in, and we will talk about that a little bit later. And in addition to all of that, our program also provides a 5-year option to continue on into a master's program after the BS, a study abroad option, and then also a co-op experience and a capstone experience. So to describe our program, we're going to talk about these 4 aspects: the faculty and the staff, the curriculum, the facilities, and then some information about the students. So starting first with the faculty and staff, this is who we are. So these different areas or subdisciplines of mechanical engineering we cover with our faculty. I myself am the chair, but we have 12 full-time faculty that work for us, each in areas of design or robotics or thermal fluids or materials. We're also supported by a shop manager and a department assistant. In talking about our faculty, I want to highlight some of our newer faculty and the great work that they're doing. So we have Anshun Pak, who understands, trying to understand fluid motion as it relates to being able to design micro-robotic swimmers. We've got Michael Taylor, who works on materials and designing materials that have unique mechanical behaviors. We have Panthea Sepperbrand, who's working with Calvin Sang to look at friction bonding. Some of the work is supported by external companies. Some of the work is supported by the National Science Foundation. And then we also have Robert Marks, who works on the education end in terms of developing our materials labs and the curriculum. All right, in addition to our newer faculty, our more established faculty have also been recognized in a number of ways. In addition, our projects that we've done within mechanical engineering have been recognized over the years. At the bottom, I've got a couple of photos of the Solar Decathlon House, which we participated in 2007, 2009, 2013. 2 of the years we finished in 3rd place. That led to the Evolve House, which is a micro house project that we did a few years ago. So we in mechanical engineering are both leaders in research, leaders in activities and projects, leaders in the strength of the curriculum that we've been able to build. Now let me talk about the curriculum and how the curriculum is built up. So the curriculum, as I mentioned before, we try to provide a balanced foundation between fundamentals, theory, and practice. We integrate hands-on labs experiences throughout the curriculum. So many of our classes, in addition to having the lecture component, also have a lab component where students get to build things. We build things for a junior design competition in addition to a senior project. And we have a strong integration of computer design, modeling, analysis in use of our computing center within the School of Engineering. The curriculum breaks down a little bit like this. At Santa Clara, everybody participates in the core curriculum, which are the liberal arts foundation. That's about 1/4 of the overall curriculum. Close to 20% for an engineering degree is in math and science. 40% comes for classes out of the mechanical engineering department, and then the remaining 15% comes from general engineering classes, including applied math, civil engineering, and electrical engineering. And the curriculum, we have a flowchart. This is available on our department website, so if people want to see a little bit more about what the classes look like. We typically have students take 4 classes per quarter. Over the 4 years with a little bit of extra space in their senior year. And these classes are organized or color-coded based on discipline. So in the early years, we have students take classes in math and physics and science with some early introductory courses in mechanical engineering. That's balanced by courses in the core curriculum. And then as they move on to their junior year, then the classes become a little bit more mech focused in these subdisciplines, leading finally to a full year course sequence for our senior design program. All right, so continuing on, the next thing I want to talk about is our facilities. And so we've done a lot of work in terms of building excellent facilities for us to work with. These include the shops and the labs that we have on campus. We train the students in a senior level lab course to learn how to use all of the manufacturing tools so that they can apply them as necessary to their senior projects. We've also been improving the quality of our equipment and acquiring new equipment through grants from outside companies. For example, the EDM wire machine was donated to us by Stryker, in addition to other equipment that we've purchased through grants. And we also have our students involved in the Maker Lab, which is a really university-wide resource where students can come in and do 3D printing and do a lot of the manufacturing that allows them to do some of their projects. And I'm going to have Felicia talk a little bit about our labs and our capabilities. Felicia.
So I think the curriculum for the Mac department is great because the labs that we have really complements the lecture well. So it actually really helps us understand the concepts that we learned in lecture by putting the theories to application. And additionally, most of our labs are also really hands-on. So, and also throughout the 4 years, there will be a lot of project work. Like Valeria said, there's the junior design project and also later on the senior design projects. But also in the labs itself, there's going to be a lot of teamwork, which helps us, the students, learn how to work together as a team, which I think is a key skill to have as a mechanical engineer.
All right, thank you. So let's talk a little bit more about kind of these projects and what goes on in the shop. And so on this slide, I've kind of just thrown in a bunch of pictures of both the students working in the lab, but also working on class activities, working on senior project activities. And on the right-hand side, we have what we have the students manufacture for their senior design, or not the senior design, but the senior level manufacturing course. And Valeria will talk about what this is and how it works and how it helps students learn how to use the different manufacturing tools. Valeria.
Yeah, as Dr. Fabris mentioned, we have this class, that Seniors Take, the Machine Shop 101L class, and it's a quarter-long class where we're developing skills that are really useful during your senior design project time, because you're really building in that time. And also it's desirable skills in industry, so it's a great class to get hands-on using lathes. We use mills, and we practice fabrication techniques with aluminum and steel. And so you get your hands-on from reading engineering drawings and actually fabricating each piece of this assembly that you see on the picture. So I actually found mine in my room. It's right here. It's a working engine frame, and it's very satisfying to see your work working. We have piston and we have it working with a flywheel. I think it's very satisfactory, and also developing those skills are going to be helpful in industry.
All right. So moving on, in the future, we're actually at Santa Clara building a center for STEM, which is science, technology, engineering, and math. In this building, we will be moving the mechanical engineering department, electrical, bioengineering, and working with physics, biology, and chemistry. So that's a project that we're anticipating to finish next summer and then starting to move in the following year. This will further enhance our lab capabilities and our shop capabilities by providing a newer facility for all of the things that we're doing. Now let me talk about our students. And being an engineer, I always like to show some data and give some information. So here's some data and information on our first year students coming in. So this information is available from the admissions office as well. So Santa Clara is a relatively exclusive institution. Our acceptance rate is just under 50%. We have some information about the GPA and SAT scores and ACT scores of the students coming in. In addition, we accept students from all over the US and from 59 other countries. And we have a good representation also of students of color and students from both private and public schools. More specifically about the mechanical engineering program and sort of what we've looked like over the years. We've, in the 2000s, we've effectively doubled the size of our undergraduate program. There's been a swing in terms of mechanical engineering nationwide, and we've sort of enhanced that by some of the projects, including the solar decathlon that we've been able to do. So our program now is essentially twice the size of what it was 2 decades ago, and we've been able to enhance our facilities, our capabilities to do that. We typically accept about or have a class of about 50 to 60 students per year. We also balance that with a graduate program that gives opportunities to continue on for a master's, and even in some cases for students to continue on with a PhD. And the growth of mechanical engineering is also commensurate with the growth of the School of Engineering as a whole over these last 2 decades. We're in a very good region in terms of opportunities, and so mechanical engineering is a strong program over here. So now to talk about the opportunities within mechanical engineering for students. We mentioned throughout senior capstone projects that provide a match for students to work on projects that are related to their career interests. We also talked about the 5-year program where students can continue on to a master's degree. We also mentioned briefly that students take advantage of student enhanced exchange program for a 1 quarter, 1 semester long experience globally, and mechanical engineering students are one of the largest participant groups in that exchange program. We also have opportunities for research through a summer research program and capabilities of working with faculty in their research labs with their graduate students. And we also have a co-op opportunity and experience. And so I'm going to let Felicia talk again about some of the senior design activities or her experience with that. Felicia?
Yes, so for the students last year, engineering students get to participate in the senior design project. And I think for me, the senior design project was a very important and fulfilling experiences that ties everything you have learned in your in my 3 years at Santa Clara University together. And also it lets us use the skills that we have accumulated throughout the years and put it to application. And so for the projects, there's a lot of different types of projects that you can pick based on your interests and career goals, like Dr. Fabris said. And also along with that, you can also choose to, there's a lot of different opportunities for you to work with different organizations and departments in school. For example, if you're interested in doing humanitarian projects that can help communities that really need technology or innovation, for your senior design project, you can choose to work with the Frugal Innovation Lab, Frugal Innovation Hub, which works with many nonprofit organizations and NGOs on various humanitarian projects around the world. Or if you're interested in doing robotics, you can work with the Robotic Systems Lab, who does a lot of partnerships with NASA and Monterey Bay Aquarium. So basically, your senior design project is a good experience and a great way for you to not only learn how to work together as a team and problem solve on a relatively long-term, year-long project, but also to start interacting and communicating and interacting and working with local companies.
All right, thank you. And so I just want to mention that Santa Clara, in the mechanical engineering itself, we've had a very long history and a good relationship with the local industry. We've always drawn students from the West Coast, and we've always placed students or alumni in many jobs at the local industry. Mechanical engineering in the Silicon Valley, although it's not immediately obvious, but there is an industry in terms of the defense industry. There's also work supporting electrical manufacturing, semiconductor work. There's a very strong growing biotech industry where mechanical engineers work. And so a lot of the companies where our students have gone to work after Santa Clara have been Lockheed Martin, Apple Computer, Stryker, Cisco Systems, Intel, Lam. So there's a very strong industry, very broad, very wide range of applications for mechanical engineers that finish at Santa Clara and then stay locally to work. And now just to, again, show a little bit more information. So this is data that's provided by our Career Center. I'm going to have the link in the next page. And it gives you an understanding of how our students do after they graduate, what the initial employment rate is. The median salary for engineering is $75,000 a year. That's the highest amongst the university as a whole. In mechanical engineering, our numbers are relatively similar to that. We do survey our alumni to see how they're doing, and we use that as a method to improve and enhance our program. And for our graduates, there's also good opportunities to continue on in graduate school. We've sent our students to many graduate schools nationwide, in addition to some of our students staying within our program for their master's degree. And so finally, I'm going to put up a couple of links for people to follow if they want to learn more about data regarding mechanical engineering. I recommend that you consult our website for Santa Clara level data. Our institutional research website provides a good perspective of what the student demographics look like. The Career Center provides information about career opportunities, and then the admissions office provides information about students coming in. And then finally, usually in these presentations, we kind of open it up for a session of questions and answers. In this case, since we're not doing this thing live, I recommend that all of you guys send us an email who have questions to the department office. Our contact information is given on the department webpage, and then we will try to respond to you and maybe even post a second video with a little bit of a question and answer discussion. So thank you all for your time, and thank Felicia and Valeria for all their help with this. And we're signing off and hoping to see you guys as first-year students in the fall.
Bye-bye.
Bye.